Hello everyone, welcome to Meda's Bridge. We train and learn. We shall start embedded systems. Let's get started. Today's our learning goal, Introduction to Embedded Systems. Hi,
Hello.
thanks for joining to exchange embedded system concepts with our learners.
Sure. Thanks for inviting me. So today, if you could see, most of our, you know, learners, students, and developers, right? You can see having a personal computer along with them, isn't it, right? My, when I say a personal computer, here a laptop, a desktop is what I meant to say, isn't it, right? These systems, what we call them as a general purpose computer. Do you know why we can call them as a general purpose computers?
Yes, a general purpose system is a computer system that can be used to perform a large number of different commonly used computing tasks.
You are right. Make a bold a statement. A large number of different commonly used computing tasks. That's the reason these personal computers are known as a general purpose computers.
And it has ability to store, retrieve and process data. As you know that we can use a computer or laptop to browse the web, send emails, type documents, play video games, create and update MS Excel, PowerPoints, edit or create videos, develop web pages, and so on. Recently, I bought a laptop which comes with Windows 11. They installed Microsoft Office and Teams.
Thank you for letting me know. Here, three takeaways. We have an hardware, and then we have an operating system, we have an application software. What you said to me, you bought a laptop which is in hardware. On top of the hardware, they installed a Windows 11 operating system. Good. That is the second layer, operating system layer. On top of the operating system, you also mentioned that the two softwares that are got installed, Microsoft Office and then PowerPoint presentation. That's nice. So now you can think of our our systems are a layered architecture. It's like a hardware, operating system, and application software. Can you now elaborate the differentiate between the hardware and a software?
Yes, of course. Hardware is the physical components of the computer such as CPU, hard disk, monitor, keyboard, and mouse. Software is the program that runs on computer. You cannot touch, but you would feel the sense of it like listening music.
One important point that we have to understand is CPU is a part of the hardware. CPU is the most important hardware component is used to process the data and instructions to control the rest of the computer system, which we can talk about little more in upcoming slides. But this is the important point, you have to note it down. A CPU and then its role in the hardware systems.
Let us look at these devices. These are also general purpose computers. Tablets, like desktops or laptop computers, they can run a many different of applications.
Smartphones can also run on many different applications, as you know, isn't it, right? So maximum functionality of our laptop desktop can also be done on the smartphones. That's why smartphones can be treated as to use for a different commonly task to be performed.
Media systems in cars, they allow users to navigate, listen to music, and connect to a smartphone. and game consoles. Modern consoles also enable users to watch videos, play music, and browse the internet.
So good. Now you see the basic understanding of why we can call these as a general purpose computers.
Now, coming to the term embedded system. An embedded system can be thought of as a computer hardware system having software embedded in it.
Yes, an embedded system can be an independent system or it can be part of a large system. An embedded system is a microcontroller or microprocessor based system which is designed to perform a specific task. Make a note, specific task and a specific functionality is what we will do with the embedded systems, unlike a general purpose computer system.
Now the components in embedded system: hardware, application software, real-time operating system.
Embedded system as a microcontroller based, software driven, reliable and real time control system. I am reiterating, embedded system as a microcontroller based, software driven, reliable and a real time control system.
You might have seen or maybe seeing PlayStation, washing machine, camcorder, and GPS are the embedded systems.
You can also build your own embedded systems using a specialized hardwares like Arduino board, Raspberry Pi. We all seeing cars. Car is a integration of like several embedded systems in it. So now is it get some sense of like how embedded systems can be identified in our life?
Yes, an embedded system is a computer system which is a combination of a computer processor and computer memory, input output peripheral devices that has a dedicated function within a large mechanical or electronic system.
The takeaway points here is a dedicated functionality which is a part of a large integral system can be considered as an embedded system, isn't it right? You can see there are many embedded systems. For instance, a smartphone, automotive, aeroplane, avionics field, medical domain, micro oven, smartphone, things like that.
Abstract model of embedded systems. Embedded systems are more limited to hardware, designed to perform specific functionality, and are computers with higher quality and reliability requirement than general purpose computer.
You're right. We have a variancy in computer systems, right? What you said here is there is a three way we can abstract the embedded systems. Embedded system can be hardware alone. Embedded system can be hardware with application software where we don't require an operating system. Certain applications we have them. There is a need of operating system to build a embedded systems. Isn't it right? So this gives a nice view of how you can model the embedded systems. The purpose of embedded systems. Embedded systems are used for data collection, storage, and representation. Embedded systems are also used for data communication. We might see embedded systems are used for data processing, like a signal processing. We can use them for monitoring control. And then embedded systems have a specific user interface application based systems too. You can see them, a video camera, basically for used for data collections. And there is a data communication. Using a Zigbee, we can have a interface between the systems. For data monitoring, example, BP machine, which we use in multi-specialty hospitals.
Embedded system is a combination of hardware, software with few attached peripherals to perform a specific functionality within limited resources. It is a typically microcontroller based software driven, reliable, real-time control system. Autonomous or human or network interactive, operating on diverse physical variables in diverse environments and sold in a competitive and cost-conscious market. Components of embedded systems: hardware, memory, CPU, sensors, actuators. Sensors. It measures the physical quantity and converts it into an electrical signal which can be read by ADC, analog to digital converter. A sensor stores the measured quantity to the memory. A to D converter, an analog to digital converter, converts the analog signal sent by the sensor into a digital signal. Processor. Processor processes the data to measure the output and store it to the memory. D to A converter, a digital to analog converter, converts the digital data fed by the processor to analog data. Now actuator. An actuator compares the output given by the D to A converter to the actual expected output stored in it and stores the approved output.
Characteristics of an embedded system. Embedded system has a functional and a non-functional distinct characteristics compared to general purpose computers.
The characteristics are: application and domain specific, should be high speed and low power dissipation, small in size and low weight, must be very accurate, and high adaptability and accessibility, must be reliable over a long period of time, operates in harsh environments,
And it is reactive and the real-time embedded systems. Quality attributes of an embedded system. We have two categories of quality attributes: operational and non-operational. Response, throughput, reliability, maintainability, security, and safety are operational quality attributes of an embedded system, whereas testability, debuggability, availability, portability, time to prototype, market per unit cost, and revenue are non-operational quality attributes of an embedded system. Category of embedded systems. Embedded systems are classified based on generations, based on complexity and performance, based on deterministic behavior. First generation, second generation, third generation, fourth generation are based out of a generation category of embedded systems.
small, medium, large, are based on complexity and performance of embedded systems. Event trigger, time trigger are based on deterministic behavior of embedded systems.
For example, washing machine, oven, automatic door lock are a small embedded systems.
Medium, automated tell machines.
Yes, automated teller machine is a medium-sized embedded system. You're right. Look at a complex systems like a satellite, digital signal processing, mission critical and safety critical systems are all considered as a large and a complex type of embedded systems.
Embedded systems classified based on functionality, based on performance.
You're right. Standalone embedded systems, real-time embedded systems, networked embedded systems, mobile embedded systems. These are all categorized based on functionality. In real time, we have a hard real time and soft real time embedded systems.
Based on performance, small scaled, medium scaled, large scaled
Embedded
embedded
systems.
systems.
Very nice. Thanks for sharing. Let's look at hardware components which we found and use in embedded systems. One way or other, every embedded system should have a central processing unit. Mostly you can find a microcontroller as a CPU for an embedded system. Embedded system reads the data from the sensor and sends the control to the activator, isn't it right? So sensor basically sends a analog signal to the our embedded system. Front end circuitry of the embedded system, we have a ADC, analog to digital converter. Analog to digital converter takes the input from the sensor as an analog signal and convert that into digital and give it to the CPU. CPU reads the digital signal and then process it and stores in the RAM. We have a different variety of RAMs used in the embedded systems. I mean, memories used in the embedded systems. You have a RAM, ROM, flash. Embedded system needs to communicate to external devices, isn't it? So we require a interface. Some devices may have a serial port communication. Some devices may have a CAN or USB. Some devices are network interface devices. Some are wireless. And hence, our embedded system should have these interfaces as a provision inside the system. RS-232, 485 are used for the serial communication. CAN, widely used interface in automotive. USB, Universal Serial Bus, is another type of interface communication. For connecting a network-based devices, we need Ethernet interface. For wireless, for instance, Wi-Fi, RFID, isn't it right? Embedded systems may have a display. Some embedded systems will have a display. Some you don't require a display at all. For instance, the router which you use in your home does not require to have a display. However, there is a remote user interface facilities as a provision provided in it. You can connect remotely through your web interface to configure your router, isn't it? Like, based out of the applications, you can use these components in designing an embedded system.
Phases in embedded system development: requirement, design, coding, testing, validation, and acceptance.
Typically, these phases are as a part of your software development, isn't it? But same phases can also be used for the hardware, firmware, and software too.
Challenges in embedded system design. How much hardware do we need?
How do we minimize the power?
How do we meet our deadlines?
Like a faster hardware or intelligent software, things like that, right? So, selection of an embedded system and then the requirement detailed out to achieve the a purpose of embedded system design is very critical precisely in this domain. You need to understand how much hardware is required. You need to understand like how much CPU is required, memory is required, what are the interfaces are needed, things like that. And also embedded system should run long time, isn't it, right? The power consumption is a place because some of the embedded systems operates with the solar systems, some are embedded systems operates with a battery, things like that, right? And also remember embedded systems which we use safety and mission critical areas, and hence we need to understand the deadline requirements of embedded system, and then you should have to design by leveraging both hardware and software capabilities.
Thanks for watching. Please like, share, subscribe, click on the bell icon, and please leave the comment. Happy learning. Thank you. Stay tuned to the upcoming sessions.